This SOS video is about the elimination method, which is one way to solve a system of linear equations algebraically. Remember that a solution is the ordered pair that will make both equations true in a linear system. When we eliminate something, that means we add a variable term with its opposite to create a zero pair. So for example, if I have 11x, its opposite would be negative 11x, and when I add them together, that would equal 0. So I just put a line through them to show that it makes a zero pair. Okay, so to solve a linear system using elimination, we're going to line up the variables and the constants, one right underneath each other. Then we get to decide which variable term we're going to eliminate. Is it going to be easier to eliminate x or the one with y? Remember, the coefficients, the numbers in front of the variable, must be additive inverse. They're going to be the same number, like 11 was here, but they have to be opposite signs. If one of them is positive, the other will be negative. Then we add each column, and then there's only going to be one variable left. We will solve for that variable. Once we get that answer, we'll substitute it in and solve for the other variable in either original equation. And finally, like we always do, you're going to write your answers in ordered pair and check your answer in both equations. Remember, in order for it to be a solution, it has to make both equations true. Okay, we're ready to practice. Here's our first pair of equations. So notice that the x's are lined up underneath each other, the y's are lined up, and the constants are lined up. So we're ready to solve this using elimination method. So I take a look at my x's and I realize these are an opposite pair. The opposite of a positive 4x is a negative 4x. So I am ready to eliminate. 4x and negative 4x is a zero pair, so I can just put a line through that. Negative 2y and a negative 9y is a negative 11y. And we add the constants as well, and we get 66. Now we solve for y. Instead of multiplying by negative 11, we divide by negative 11. You do that to both sides, and y equals negative 6. So we've found the answer for one of the variables. Now we need to find the answer for the other variable x. So I get to pick my favorite equation. I'm just going to pick the one on top. I'll rewrite that. 4x minus 2y equals 12. And now that I know y equals negative 6, wherever I see y in this equation, I'm going to replace it with its value, negative 6. So I rewrite this 4x minus 2 times negative 6 equals 12. And now you're going to solve for x. Pause the video, solve for x, and start again, and let's see if you did it correctly. Okay, how'd you do? Remember, a negative 2 times a negative 6 is a positive 12. And now to get rid of the positive 12, we subtract 12. Remember, we have to do that to both sides. So we have 4x, positive 12 and negative 12 is 0. And then also on this side, 12 minus 12 is 0. So 4x equals 0. Instead of multiplying by 4, we divide by 4 and x equals 0. So now I have a y value and I have an x value. I'm going to write that as an ordered pair. Remember that our x value comes first. This is my x value, this is my y value. And we are going to check to make sure that that point works for both equations. The way we check, we write one equation, we substitute those numbers in, 4 times 0 minus 2 times 6 equals 12. And now we do the math. 4 times 0 is 0. A negative 2, oops, this was a negative 6, excuse me, negative 6. A negative 2 times a negative 6 is a positive 12. And 0 plus 12 is 12, and that's identical to this side. Okay, now remember, it has to work for both equations. So we're going to rewrite the next equation, and we'll do the same thing. In place of x, we'll put the value 0. In place of y, we'll put the value -6, and we'll see if this works. -4 times 0 is 0. -9 times a -6 is a +54. 0 plus 54, 54 equals 54, and my answer is correct. So you have just solved a system of linear equations by using the elimination method, by finding one term and creating an opposite pair to it. All right, let's take a look at this one. I look at my x's, and they are not a 0 pair. I look at my y's, and they're not a 0 pair. But I realize I can make this a 0 pair if I multiply this by a negative, because that would change that to a -3y, and this would be a +3y, and that would make a 0 pair. So let's do that. I'm going to multiply this whole equation by -1. And when I do that, -1 times x is a -x. -1 times a +3y is a -3y. And -1 times a +15 is a -15. Remember, to balance the equation, we have to multiply every single term by that number outside. Now, I have a +3y and a -3y. That's a 0 pair. So I'm able to eliminate them. Let's add this. -8x and a -x is a -9x. A +3y and a -3y is a 0 pair, so I'll put a line through that. And -12 and a -15 is a -27. Okay, now instead of multiplying by -9, we're going to divide by -9. Division property of equality, we'll divide both sides by -9, and we get x equals 3. So that's our x value. Let's find our y value. Pick your favorite equation. I'm going to pick the one on top because it looks a little bit easier to work with. I'll write x plus 3y equals 15. In place of x, I'm going to put the equivalent value. So I see x here. I'm going to replace it with 3. And I'm going to solve for y. Okay, stop the video, solve for y, and start up again. Okay, how'd you do? We subtracted 3 from both sides. We got 3y equals 12. Now instead of multiplying by 3, divide by 3, y equals 4. Okay, we're ready to check. So we write check, and we write the ordered pair. Our x value is 3, and our y value is 4. Let's write one equation. X plus 3y equals 15. We're going to replace each of these variables with the values that we found. So in place of x, we'll put 3. In place of y, we'll put 4. And now let's do our math. 3 plus 12 is 15. And 3 plus 12, that is 15. 15 equals 15. Check. Right, let's write our other original equation. -8x plus 3y equals -12. -8 times 3 plus 3 times 4, that's our y value, equals -12. And let's do the math. A -8 times 3 is a -24. +3 times +4 is a +12. And a -24 and a +12 is a -12. And is that the same as a -12 on this side? It is. So you have just made sure that your ordered pair worked for both original equations. And that is how we solve a linear system using the elimination method.